Hello, everyone. I'm excited to share with you my conversation with industry expert and serial entrepreneur Yegor Anchyshkin. Yegor is co-founder and CEO of Instock, a warehouse automation company that approaches things in a unique way. He also founded, ran, and sold a bunch of other companies in the e-commerce domain, so he brings a wealth of experience to the table. We talked for more than 2 hours, so sit back, relax, and get ready to dive into the world of warehouse automation. It would be good if you could just very briefly explain what you do and what Instock does and why you founded Instock.
Sure. So my name is Yegor Anchyshkin. I'm in e-commerce fulfillment for the past 14 years. Instock is an automation company, a goods-to-person automated storage and retrieval system, a new kind of system where you combine certain elements of cubic system and like SRS based on AMR rather than shuttles. We are I believe, the most flexible system that is available on the market today. So we can deliver the widest range of throughput capacities and storage densities based on the same number of elements, right? So you can get a goods-to-person system that has very good storage density, occupies the full volume of the room for very reasonable price. So we do it, roughly speaking, better, faster, cheaper than other players. We came to Instock from our experience. So this 14 years were split, like 7 years invested into manual processes. I founded a company called Zakaz.ua, which became almost like a monopoly grocery delivery company in Ukraine, and then it expanded to Boston, Massachusetts. And then the next 7 years were with automation, starting from the company called Takeoff Technologies, where I was CTO from the beginning of that company, and then Instock starting in 2020. So we had a front row seat in delivering advantages of automation, but also fighting the challenges of automation. And basically, Instock is our attempt to remove the challenges, to redesign everything from scratch so that the system is truly flexible, truly convenient from an operator perspective.
So this is very interesting. Now, you mentioned that Instock is an attempt to address some of the shortcomings that you've observed in the industry. And the one thing that you just mentioned was designing everything from scratch, every single time. And I can relate to this because that's indeed what happens in many cases. But what are other problems that you've observed with existing technology that you are addressing with Instock?
So you can group the issues into what we've seen is like 2 big groups. One is inflexible, and another is narrow efficiency range from an economics perspective. So let me elaborate a little bit. Inflexible mostly comes from the necessity to address movement in 3-dimensional space, right? It's like you have inventory that is stored everywhere, so at 6-meter height, right? You have bins with inventory. So how do you make something that moves and brings that inventory to you? So we're discussing goods-to-person system, right? So operators are stationary, associates are just standing, maybe doing a couple of steps left and right, and inventory comes to them. And to address movement in 3-dimensional space, the traditional approaches are related to gears, pulleys, lifts, rails, and so on. It's natural, but what comes with those approaches is requirements to precision. So you have very tight tolerances to those mechanisms. In those mechanisms, like you are requiring pretty good execution of every element, or almost every element. And those high precision requirements, they proliferate through all phases, from manufacturing to installation to maintenance. And that why the systems become inflexible, right? So what I mean by inflexible, you cannot change the size of the system. You can't reconfigure it. You can't redeploy it. Many elements are one-off. So you cut certain piece and you can't reuse it. You cannot change your mind. You're like post installation that you want a different ratio between throughput and density. So all of the decisions in the design are made preemptively in the design phase about the future operations. And typically you have to predict your future operations for 2 or 3 or 4 years ahead, because that's a typical ROI of the system, right? And that's where we come to the second group. Yeah, and that's when we come to the second group of deficiencies. They're around economics and narrow efficiency range, right? So let's say you are buying a shuttle based system, and somebody will tell you, hey, you have 2 workstations, 2 picking workstations, and each has 600 bin presentations per hour throughput. And you say, well, okay, this is 1,200 bin presentations per hour, but I'm just starting. I have 20 orders a day in my e-commerce. Like, why do I need 1,200? How do I use this remaining 1,100 of unused throughput? Well, and the vendor will say, it will just sit there. And then you will be growing. At some point, you will hit the moment when you have a certain number of orders and you are really using, let's say, 1,200, and then you'll continue to grow. So there will be a brief moment in your evolution when you are using efficiently the system, but there will be 2 very long periods when the system is not efficient. So you need the system that adapts and grows with your business. You need technology that adapts to business, to operations, rather than technology that asks operations to adapt to tech. And that's a big difference.
Yeah. Well, this is very interesting. What you're saying is that for the most time, the system is either too large or it's too small. And there's only a very short period in time where it's just exactly right-sized.
If the system cannot be adapted and grow with you, right? Or it's not always growth, right? You want to scale up, but sometimes you want to scale down. It happens. And there are not too many systems that can actually do those kind of adaptations. So we put this into the core of our architecture. We wanted a system that is highly flexible, and we wanted operators to be capable to scale up, scale down, calculate very easily what the cost of scaling would be. It should be very transparent and easy.
Yeah. Well, this, the fact that when you're ramping up a system that, well, you first in the engineering phase, you're setting a certain capacity level for the system, which is based on a design year and an expected growth rate until that design year. And so by the time you ramp the system up, the system tends to be way too large, right? If you're expecting any significant growth in the next couple of years. But the interesting thing is that in the business case calculation, people forget that the system isn't fully utilized when they start using it. So they think there's a return on investment in 3, 4, 5, 6 years based on full utilization of the system, which is almost never the case. And so the actual return on investment comes much later, can be 7, 8, 9 years.
It's basically, first of all, this is not an easy calculation, because you're looking into the future, you're predicting what kind of sales you will have. And typically this is per geographic area, because it's a physical automation, so it serves from geography. And obviously from a mathematical standpoint, the smaller the area, the harder it is to predict. Like the smaller the volume, the more fluctuations you have per area. So when you speak the words micro-fulfillment, when you are discussing sites and installations that serve a couple of miles radius, it's really hard to predict.
Yes.
So it becomes almost like a contradiction to itself. You want to get smaller, but the smaller you get, the more fluctuations you have, and so the harder it is to predict, and so the more confident you have to be in your prediction, which is very often impossible, and therefore you more and more you cannot afford capex.
Right. I mean,
right, because you're putting $2 million into something, and you may be 50% off with your traffic.
Yes, yes. I mean, the business case for micro-fulfillment is, well, it's difficult. Let's put it this way. Even under full utilization, even if you assume full utilization from day one, I claim, and I've never seen any evidence to the opposite, that most micro-fulfillment solutions will never pay off, because the productivity that they can reach is just not sufficient to deal with the very thin margins that you get in, say, grocery. Of course, there are other business segments where it could make sense, but micro-fulfillment, we mostly talk about that in the context of groceries. And so
true. But like, if we start saying the words not pay off, like we're already giving some kind of binary signal, right? So it's a mathematical calculation, it starts to be. So we have to be more specific and precise, like what do we mean by micro-fulfillment? How much of the area is covered? What's the square footage? It became a marketing term. It's not anymore some kind of, and that's one of the things that I see in the young industry, right? The industry is young. There is so many marketing terms flying around. It's very easy to confuse a client, and I mean, good salespeople can use it to their advantage to kind of wrap a client in certain reality distortion field and sell them what they want to sell. But I mean, and that's where I see a big role that academia you should play, right? It's defining the terms, bringing certain mathematical or scientific or technologically savvy background to certain calculations, so that the clients who are technologically savvy can actually go and check and calculate themselves something, maybe. So take micro-fulfillment, for example. What I heard from other players, and obviously I worked in one of those pioneering players, micro, they are saying it's something that is smaller than 10,000 square feet.
Yeah.
Right. So let's say 1,000 square meters installations. And of course, we discussed automation, because there was, for example, GoPuff, who that's I heard from. They were the first from whom I heard that, hey, we're fulfillment, we're micro, so it's a micro fulfillment. We have 500 micro fulfillment. Like, who said the term doesn't say it's should be automation, right? So if we're discussing automation, less than 10,000 square feet. So how many bins, how much inventory can you fit into 10,000 square feet facility? Even if you, let's take, first of all, it's a 10,000 square feet for the whole facility. It's not the actual grid or rack that stores the inventory. So the storage of inventory can occupy maybe 30 to 50% of that facility, let's say, and you can fit maybe 6,000, 7,000, 10,000 square bins with the old school system.
Yes.
Right.
Yes.
And what do you mean when you have, let's say, 10,000 bins? What does it mean? It means it can cover a flow of several hundred large grocery orders a day. Let's say 400 grocery orders a day. Right. So all of the inventory for those orders can be stored in the. So I think if you truly have the flow of, let's say, 500 orders plus already being served, being picked in that supermarket, you are getting into the territory when you can have a positive ROI, even if you're asked to pay a capex.
Yeah. I don't.
But it's only if you have the flow. All right, we can get into calculation.
Yeah.
If you have already the flow, so let's say 500 orders a day, you have 20 order lines, so 20 SKUs in each order. Let's say every SKU is like 1.5, 2 pieces. Yes, I think we can get into calculation. You can be already in a positive ROI territory. But of course, with a system like Instock, it's much better because you pay as a service.
Yeah, well, that's a different story. Yes. So I mean, let me just comment on the traditional micro-fulfillment centers briefly, because this is such an interesting topic. I've been fascinated, like, if I phrase it positively, I've been fascinated by the topic for a couple of years now, and I've criticized the concept and the technology used for the concept. Now here's why. I've done it so many times, but every time I struggle where to start. So first, about the term, you're right. I mean, there's a lot of use and misuse of the term micro-fulfillment. I've seen people on LinkedIn apply, like, slap micro-fulfillment on like 50,000 square meter large distribution centers because they equated micro-fulfillment with automation, which of course is nonsense. And they didn't understand the micro part of micro-fulfillment because they just don't understand it. But yeah, when I talk about micro-fulfillment, I think about the original definition that came from companies like Takeoff, or basically the Dematic has.
The first one I heard was from Common Sense, which then became Fabric.
Yes.
Right. I heard the first time I heard micro-fulfillment words were from CEO from Common Sense. That's where in 2014 or 15.
I didn't even know they existed back then. Okay.
Yeah, they were 2 or 3 years earlier than Takeoff.
Okay.
And then like there was a little bit of like who coined the terms, but it doesn't really matter, right?
It doesn't really matter.
The term, it has its own life now. Yes. And I think whenever we talk seriously, we start talking about numbers, and we kind of put away the terms. But yeah, back to your idea of
like, say, 1,000 to 3,000 square meters, like 6 to 10,000 bins, storage space. Yeah. So this is what I understand when I say or when I hear the term micro-fulfillment. Now, there's a lot of problems with the concept, and there's a lot of problems with the concept in combination with the technology. So first of all, because the number of bins in the storage system is so limited, you can only get a fraction of the inventory, like of the SKU range that you have in a typical store into the micro-fulfillment center. That's a problem in some stores in Europe. In the United States, where the SKU range tends to be very large, it's a bigger problem.
Wait, but just to emphasize, you said conceptual and technological. This is a technological issue, right?
No,
because it's not the issue with the concept.
It's a
you can fit much more.
True. Yes. So conceptual and technological are related in the limitations of the bin. Yes, of the bin space. Yes.
So, for example, we can fit 5,000 bins in 2,000 square feet, and at the same time have normal throughput. So this is not a conceptual issue, I believe. This is technological issue.
Okay. All right. So I agree. So if I stay within the boundaries of the mature existing technologies, then for me it's a conceptual thing. But you're right. With better technology, we can address that. That's right. So, but let's assume a shuttle system, because you've got your history with takeoff systems, and Dematic has the same thing, and SSI tried to at least slap the MFC label on some of their shuttle systems. Savoy has the same thing. So that's two. Like you can fit 2 or 3 shuttle aisles realistically in the space, right? And so you've got 6 to 10,000 bins. Now, if you have 60,000 SKUs, then obviously that's a tiny share of the SKUs that you can fit into the system. Now, typically, traditionally, what you do when you build a goods-to-person system is that you want to automate the slow-moving SKUs first. The reason
slow-moving?
Here's why. So you can pick pretty efficiently any SKU that is fast-moving, because it's not so many. Like the fast-moving SKUs that represent a significant share of order lines, they're not very many. It could be like 50, 100, 200 SKUs, and you can condense them in a very tiny area where you can.
This is a keyword, in a tiny area.
In a tiny area, yes.
So it's like, look, what you just said. you have a power over space, right? How to organize SKU storage, inventory storage in a space. But if you are giving an existing store, let's say you are a huge hypermarket in Germany, and you want to pick out of the 60,000 SKUs, then you want to do in-store picking, then you don't have power over space. Your
not in the store,
frequency movers,
not in the store. You would have to have a dedicated area in the fulfillment part of the warehouse. So you would have to have a manual area. So that's how you traditionally do it. You have your fast movers in a clearly designated, dedicated area where you can pick them very efficiently. And then the slow movers, this is where you normally lose the money. This is where you lose time and productivity in a manual warehouse, because your ratio of walking to picking becomes quite
exactly high. Travel time to pick time, right?
Exactly, and that is worst. That is worst for slow movers. So those are the ones that you want to stow away in an automated system, so you don't have to walk through them. So you can have your cake and eat it too. You can have a manual area that is small, covers a significant share of order lines, and you operate that area manually. And then all the rest you put into an automated system. So the great benefit of that approach is that you significantly reduce the CapEx, because you already take 20, 30, 40% of order lines out of the automated system, which can save you a couple of million euros. And the system becomes much smaller. And then you have the productivity benefits of goods to person picking for the slow movers, and you don't have to replenish the goods to person system all the time because it's only slow movers.
Well, you have to replenish. So you kind of, for this comparison, you invented like one situation where you have high frequency, high velocity SKUs in manual area, and then slow velocity or mid to slow B and C you have in the automated.
Exactly.
And you have to replenish both, right?
Yes, but the thing is, if you have a manual area with fast movers, then you can pick products basically directly out of the source load carrier, which could be a pallet, for instance.
Correct.
The thing is,
but you also have to merge, right?
You have to merge. Yes, that exactly. In the moment you split up the inventory, you have to have a consolidation process, which of course is painful, but you have to have it anyway in the micro-fulfillment center, and you have to have it in many other systems too.
Well, you have to, if you again
in MFC you have to have it, because
we have to separate in the merge the physical aspect of it, so the material flow aspect of it, and the information flow, because I can show you videos very funny when the bins are right near each other, but to understand that these two bins and these three bins belong to the same order, it's an information decision, right? Like
yes.
So in when you put all of the inventory into automated system, it, like all normal systems, they support the idea that once you get the orders out, they will be together, and there will be easy way to identify that this number of totes belong to the same order, and you can therefore stage them conveniently in the order you want. Whereas in the manual plus automated scenario, you also add a necessity for material flow definition, right? So the automated will kind of spit out parts of the orders on one end, and then you have manual, and then you have to have this material flow to merge orders, but also it has to be supported on the information level from some kind of other system.
Yes.
Because the automated part will not know how the orders are organized in the manual part.
You need to have some management system that is on top of.
And that's why you said painful, right? Because like if you have both very well defined, it's a time.
Painful because you lose productivity. That's why you have to touch the items again, and that's you know, in the end everything is about
you're not touching the items, you're touching bins.
It depends. I mean, it depends if you have transportation if you have transportation constraints, then you want to ship as few bins as possible. So it could very well be that you have a bunch of bins coming from the manual area, and you have a bunch of bins coming from the automated system.
Now you added capacitated vehicles routing problem when the capacity is a real constraint. And when you, of course, I agree. Once you start touching items for the second or third time, it is by now so much pain that it's easier not to do the project at all.
Exactly, and that's exactly what's happening with micro-fulfillment centers. Let me finish the story, and then I get there, right?
Sure.
So I explain why I think so. So in the traditional systems, you would have the split between manual and automated along the fast mover, slow mover demarcation line, basically. Yeah? So that's the original idea, because you don't need to fix a problem with fast movers. You only need to fix a problem with slow movers. The fast movers are doing fine, very few, and you can pick them very efficiently manually. All right, so in an MFC, they turned it around, or at least in the MFC concept that I've seen, this was turned around. So you would have the faster moving products in the automated system, and you would have the you would keep the slow moving products in the supermarket. And you can only do it this way because there's so many products. So you have to decide which ones are you going to put into the automated system. You can't put all of them into the automated system. There's not enough bin locations for it. So you have to take a subset for reasons of space availability. And this, at least to the information that I've received from all the MFC vendors, have always been the fast movers, whereas the slow movers stayed in the manual store area, in the public store area. Okay, so this comes with two problems. Well, first of all, if you put fast-moving products into a goods-to-person system, you are fixing the non-broken part, because you could, if you wouldn't force yourself to stay within the constraints of a store, of an existing building, but you would set up a dedicated warehouse, then you wouldn't have to do this. Now I've kind of forgot what I wanted to say.
So first, you're saying you're fixing the non-broken part.
Oh yeah, exactly. You're fixing it. So the fast-moving products, you don't need to automate them, because you can pick them manually in a very efficient way already. So you don't have to put them into an automated system. So the resulting productivity benefit from having fast movers in the goods-to-person system is comparatively low, if there is any at all, if you consider that you have to go through a decanting process first, and then probably through a consolidation process after the picking process. So if you take all of that into account, then you might not even have any productivity benefit from having the fast movers in the automated system. Plus, because there are so few locations in the automated system, you have to have what's called a compacting process. You probably would have to work with compartments, with compartmentalized totes, in order to be able to fit more SKUs into the system. So you have very low inventory of most SKUs in the automated system. And then every time, well, and because space is precious, every time compartments become empty, you want to fill them up with something, but you can't go through a regular replenishment process where you start with empty totes and you just replenish any SKU that comes. No, you have to go through a compacting process to free up totes that are like half empty and fill up other totes that are half empty, right? So that's touching the items again. So if you take all of that into account, then you're probably losing productivity in the goods-to-person system as compared to picking those products manually. So that's the first problem.
Oh, it's only the first
just one. That's just one.
Okay.
Then,
the second one.
Well, the second problem is that you still have all the slow movers in the store. So you retain the troubles of having to pick slow movers. And when you pick from the store, there are two big factors. One is productivity, which isn't extremely high in the store. Now there are ways to make it better, and there are ways to do it worse. And I'm sure companies have come a long way improving the in-store picking process. But there's one problem which they cannot solve, which is inventory management, inventory control. You know, if you're sending an order for 5 avocados as a customer, and that order goes through, right? So you assume you will have 5 avocados by tomorrow afternoon.
Of course, yeah.
And then the picker goes to the warehouse, and somebody just purchased the last 5 avocados. Then there is no inventory left, and this is the situation you will never be able to avoid in a store. in a public area that you share with customers. And that's actually the bigger problem. If you ask, at least according to the service that I've been presented, customers are extremely unhappy about lack of reliability for online orders. And I have friends, for instance, one of my friends, during COVID, he ordered at Kroger all the time. Or was it baseless? I don't even remember. He told me that every single time some item was missing, every single time.
Yeah.
And he kept doing it because of COVID. But, in the moment COVID was over, he stopped doing it because, that's not, you just can't accept that something's missing all the time.
Yeah, please.
That's the second problem.
Is there a third one? Because I will start crying. I go, you speak through 10 years of my life fighting with these issues. What's the third one?
I'm sorry, I didn't want this.
No,
I didn't want to hurt your feelings.
What's the third one?
So the third one is that let's single out let's single out the productivity issue a bit more. Let's emphasize the productivity issue a bit more. So let's say we've got two shuttle aisles, right? And we have limited building height. Let's say 10 meters or something like this, right? That's
a big building, right?
Yeah, that would already be quite okay. So how many shuttles do you get into 10 meters?
Well, so you can have one shuttle per level. You
Yeah.
can have maybe 8 levels.
Yeah, 8 to 10 approximately, right? So Dematic was advertising 10 levels for 10 meters approximately.
Okay, 1 meter per level. Okay.
Yeah, approximately. Give or take 2. All right. So then, with the shuttle system, you have this problem that the capacity that you have available is divided into little bins, so to speak. You don't have one capacity for a shuttle system, but you have many little sub-capacities. So you've got one capacity for an aisle, but not even for an aisle, but then you have separate capacity for each shuttle level. Plus you've got the capacity of the lift. So in a very naive calculation, you would say, well, we have 10 shuttles. Each shuttle can do, in theory, can do something like 45 order lines per hour or 45 storage and retrieval movements per hour. So with 10 levels, we get 450 bins in and out per hour. Okay. But that assumes that you have equal utilization of all shuttles all the time, which you never have. And you don't have it for several reasons. First of all, statistically, it's very unlikely that all shuttles receive the same demand because the products that you have stored in the various shuttle levels, I mean, they say they differ in demand. And especially because we're talking about faster moving products, which have somewhat unbalanced.
Well, you assume predefined storage locations for an SKU, right? But that's a software decision that may kind of jump. You may decide to store that SKU on level 1 in the first cycle, and then 10 minutes later it's stored on level 5. Like every SKU stored in multiple bins.
Yes, if you have extremely good software and you have very reliable data that makes it possible to make any predictions about future demand, then yes, you can do this, but you will still always have the problem that there are imbalances between the different shuttles. So shuttle 1 might be idle while shuttle 2 might be very busy, but shuttle 1 cannot come to shuttle 2's aid and help it, right? So that's not going to happen because there's no possibility of roaming. So each shuttle fences for itself, which effectively leads to the situation that the overall utilization of shuttles is significantly lower than people assume. And so the amount of bins that you can get out of a shuttle aisle, of any shuttle aisle, is by tendency significantly lower than what you would expect if you just looked at the capacity of shuttles and multiplied it by the number of shuttles.
Well, yeah, I mean, I get it. You speak certain calculations that are typically not done on the client level, on the customer level. This is more designers of systems, those who really think like how the cents and dollars for each shuttles are distributed and how they're utilized. And yes, shuttles are not utilized.
Yeah, I'm thinking in terms of material flow. I'm not even thinking about dollars. I'm thinking purely in terms of material flow.
Yeah.
And so, yeah, and this is something that's not been done by clients. That's right, but it's also not been done by many warehouse automation vendors, which is very disappointing. They don't think this way. And the thing is, in grocery, when you have something between 20 and 40 order lines per order, it becomes even more difficult because, you could balance the utilization of different shuttle levels somewhat if you had something like 1 or 2 order lines per order, because then you could basically say, oh, now I'm going to fulfill this order because that order requires an SKU that is in level 10, and level 10 has spare capacity.
Mm-hmm.
But when you have 25 order lines per order, or 30 or 40, then you cannot necessarily afford the luxury.
And they have to be picked in a certain sequence.
Exactly. And you have the sequencing requirements that, like the crash classes that come on top of this. So not only do you have 25 order lines, but you have crash classes. And if you really do not understand what you're doing as a warehouse automation company, then you build a one-to-one pick station.
You're picking one order at a time?
One order at a time, which is exactly what Savoy did for Coop Liguria, if I'm not mistaken. I think they built a one-to-one pick station. And, having a one-to-one pick station has been very fashionable for a while because Ocado have one-to-one pick stations. And everybody wanted to be like Ocado, but they did not.
Oh, I didn't know everybody wanted to be like Ocado. Okay.
a lot of supermarkets wanted to be like Ocado.
That's a European trend, probably.
Yeah, probably yes, agreed. So they looked at Ocado and they looked at Ocado's productivity numbers, and they saw, oh, Ocado picks 800 items per hour. We want to pick 800 items per hour. We need one-to-one pick stations. But they were disregarding the fact, they were ignoring the fact that Ocado has a cube storage system where you have complete roaming on top of the shuttle, and you don't have all these capacity division problems that you have with shuttle systems.
All right, I didn't expect that, but let me come to be an advocate of MFC and push back on all of the 3 points.
Yes, please do.
So first of all, it's a setup, right? So you set it up in such a way that MFC doesn't work. And I agree. In the scenario that you described, when you have an ability to define space for a material flow for manual operation, and you're installing in parallel certain automation, then the rules are slightly different. But even with the high velocity items, you still have travel time, right? So even if it's smaller, you can make it more efficient in a confined space. It's still not 0. It's 0 only if you are selling 1 SKU.
Yes,
and here is a pallet of that water or bananas, and you're selling only that 1 SKU, and you're just retrieving items. Once you start to organize space and people start to walk and the travel time is non-zero, it makes sense to save travel time always. And then the second part of your setup, you said, okay, so I have control, but I have control means I'm not anymore in a store environment, right? Because typically in a store, even if you have a little back room that they can give you, and I speak from my experience, I was working with Auchan, Metro Cash and Carry, with supermarkets, hypermarkets, various sizes of stores, 30 chains over the past 14 years. Typically what happens is that the store can give you very confined space. very small space. And that space is not enough, not only to install automation, that space not enough even to organize a nice manual process. Even if you take only, let's say, 1,000 SKUs, the highest velocity items, it's a rare situation that you can fit and organize a separate picking area for those 1,000 items. Even if you have a daily replenishment, because the frequency of replenishment is another variable here, right? If you're replenishing every 2 hours.
Exactly. You have so little inventory in the MFC that you have to replenish frequently, which, shoots down your productivity even more. And I agree with everything you say, but that's why I say it's conceptually wrong. MFCs are conceptually wrong.
But let me get to how it can be right, right? So, okay. These setups, they don't work nicely. So you have very little room in a store, then you kind of think what to do with that room. Or you have a dark store, but then the question is how to organize grocery in a dark store is just a separate question, because what I like about grocery stores is all of those interesting departments that are typically perimeter departments: deli, meat, bakery, fresh fruits, vegetables, and so on. This is like all of the juicy stuff. And once you move into the dark store, all of that juicy stuff has to be, it can be still there, but first it has to be present in a dark store environment. So yeah, you are building a separate specialized store, and now you have to package all of that stuff separately, right, to make it efficient, because it's the last thing you want to do is to have a hot bar and not package individually and pick into the bucket once the order has arrived. Like, this would be obviously a ridiculous process. So everything is prepackaged, and then you end up with like normal dark store players, direct to consumer, like, I don't know, Picnic, the Norwegian one, what's the name? Uda, yeah, the Frisco in Poland, Ocado, and many others. Like, they're doing good job, but it's a specialized grocer. You're not talking anymore about, oh, there was a grocer and they utilizing the existing stores. No, you're building separate facilities.
Yes.
Right. And in those facilities, again, automation may play a very significant role, because you are now even more in control of the form factor of that facility, how to organize it if it's a separate facility, and therefore you can fit all of the inventory into the automated goods to person system. But of course, I assume that there should be a good density. Density is a universal value, meaning the less space you're using, the less you're paying for real estate, right? But in a dark store environment, I totally agree with you that it's probably not, when you calculate everything, it's probably not a good idea to have huge split, like 40% of lines are picked manually, 60% are automated, because if you have 40-60, then you have a huge merge. But I do believe that it can be very efficient if you have high storage density, high throughput system installed, and you store everything there, both high velocity, low velocity. And even if you're cooking salads, right, and cutting ham, you're putting those in packages, and those packages also go back into storage, into chilled area, and then everything is picked in one go.
Yes. I mean, the thing is, both the size of a system and the cost of the system is driven by one of two variables, either the storage requirements or the throughput requirements, which is, and
why one of the two? It's maybe driven by both.
They're rarely ever balanced. So it could be that you have, I mean, let me phrase this differently. If you're designing a system such as a shuttle system, a mini load, or even an auto store system, you make a decision about the number of storage locations you want to have, and you make a decision about the number of ASRs that you want to have. And those two you want to bring into balance. And depending on the system that you want to use, that's easier or more difficult. So for instance, if you have high storage requirements, but you don't require a large amount of throughput, then you would probably take something like a mini load crane or mini load cranes, because they're very cheap and, on a per storage level basis. And they're reliable. They have advantages such as, one mini load crane can serve all vertical levels. So you don't have this capacity division that you have with shuttles. However, if you have extremely high throughput requirements, but you do not have 100,000 SKUs, then you probably build a shuttle system, depending on the order structure also, right? So if we're saying like two order lines per order, or one order line per order, and you have high throughput requirements, then that's the domain of shuttle systems. You wouldn't build a mini load system, because then you would have a lot of mini load aisles just for the throughput requirements, even if you do not need the storage locations that come with every additional crane that you build. So you want to select the right system based on your balance of dynamic and static requirements. And typically one of them is leading, right? One of them gives is leading the decision. And so I forgot what I wanted to say. I've had a long day already. I'm sorry, I'm a bit confused.
Yeah, it's the end of the day. It's
I got up at 5
AM
in
time
the morning.
for me. Oh my God.
Yeah. So I might need to get a coffee in between, but what did I want to say? So anyway, so if the size of the system, if the dimensions of the system are driven by throughput requirements, then if you decide to take out the fast-moving products and to put them into a manual area, then you can save significant investment costs. That's almost always. So of course, from a process perspective, it's much easier to have everything in one system, which is also why many companies are suggesting that, especially auto store distributors. They always say, well, it's much easier if you have everything in one system. You have one picking process, no consolidation. You can have pick and pack and, whatever. It's much easier. And they can also sell more of their system. They can sell more bots and they can sell
That's
more.
secondary.
Yes, sure. No commercial interest whatsoever.
Yeah.
So, so from a process perspective, that's not bad to have everything in one system, but you're probably paying a significant premium to have that luxury.
Look, let me just react quickly. There are a lot of things that you mentioned. First, cost, and second, when you are kind of modeling in your head, I see that you come from a perspective of the whole system that existed 5 years ago, 10 years. Yes. What's real, right? What is practical?
Yes.
I think with Instock, and maybe there will be new systems emerging, those limitations go away. Meaning, first of all, you don't have to decide all of those questions up front. So you can have more throughput later, fewer storage locations. You can have more storage throughput later, slightly lower throughput. So the system is more fluid in both directions, in throughput and density. And the cost of it, you're not losing a shirt by putting everything into your system, even if this everything is what we talk about, like more than 10,000 SKUs, couple of days of inventory on hand, let's say 20,000 SKUs, right? Because at 10,000, you probably would still do it manually. So you take bins and you split them into 4, 6, 8 cells, and it's still, I think, more economical for Western Europe and for America to do it with putting everything into one system, because again, you're saving so much on the travel time and on space that at least I can speak for our prices, right? It would pay off. It would pay off.
Yeah. In terms of space, I would probably agree. If you have a very dense system, then the amount of space that you save is probably overcompensating the extra investment in the automated system that would be required to make space for the bin locations. I agree in terms of space. However, when we talk about throughput, you still, I mean, that's a concept that's a conceptual necessity. If you put everything into one system, you will still need more of your robots, because then you have to deal with all the order lines.
Of course, you need more moving parts moving simultaneously within the system to enable throughput capacity.
Exactly. And then if you, now let's make a thought experiment. Let's say we start from a situation where you have 100% of all SKUs in an in-stock automated system.
Yeah.
Okay. And now we look at the top 10 fast-moving products. And we figure out, well, you know, we sell like 2 pallets of bananas every day.
Yeah.
Why do we repack 2 pallets of bananas into totes every day just to take them out again? So
you mean that from a replenishment decanting perspective, when you're picking from a pallet, you may not like even break the pallet, right? You're just cutting the shrink wrap.
Yes.
And you're picking right from the banana box, right from the pallet that is on the floor.
Yes.
You're losing all of the vertical height above the pallet.
True.
This is not utilized anymore.
True.
But you're right in terms of, like, yes, you're decanting. There is no decanting of bananas.
Let's place the pallet directly next to the picking station where you anyway lose the space, right? So then,
well, you not necessarily lose the space near the workstation there. But
is there anything above?
Yeah, it's
above
your space. I mean, you can you don't lose the space above picking station in Instock. It's a case for, let's say, Exotech, but not for Instock. In Instock, you're utilizing the space over the workstation.
Oh, I didn't know this. This wasn't
because the workstation is embedded into the body of the grid.
I see.
As well as AutoStore, right? With AutoStore, you see the portion of the workstation that is sticking out. It's a tiny portion relative. It's like an iceberg. You see a little bit on top, but the bigger portion of the workstation is in the body of the grid. And by the way, it's a natural trade-off, right? That thing that is in the body of the grid is reducing your storage density. So the more workstations you have in AutoStore or in Instock, the less of the density you will have in the system, even though you start from the very high number.
True. You're right. It depends for AutoStore. It depends a bit on the type of picking station we're talking about.
Yeah, of course. So it was a staging fusion port. We'll use much more, and then.
Because they need more buffer space, and but you're right. Anyway, so if we simply talk about productivity,
but coming back to bananas, right?
So let's talk about bananas. So if we place a pallet of bananas close to the pick station, or even separately from the pick station in a manual area where there's a dedicated separate picking process, then because we don't have to go through the decanting process, and because we can pick very efficiently, very efficiently,
but it's not zero. You have to make an assumption. What's the travel time to bananas?
Well, if we only have bananas, let's say the travel time is like we walk 2 meters because we only have bananas at the moment. Right?
Okay, so we
do a multi-order pick. We do a multi-order pick, so we pick to several orders simultaneously into dedicated order bins. Clean order bins.
Okay.
You would pick faster than you would pick out of a goods to person station.
Well, so again, let's just
if you have a backlog of orders.
Let's compare time. The pick time is the same, right? When you approach bananas, when you're at the banana station, sort of like, right? You're reaching, taking in a banana and putting into whatever multi-order dolly you have in your mind. That's the same time as you would reach out into the goods to person system into a bin, pick up banana, right? So the actual item movement is the same. Now, what we're comparing? We're comparing decanting time in the automation system, plus, of course, the cost of the automation itself,
yes,
versus the let's assume that the putting the pallet on a place is 0 in the manual scenario, 0 cost. We're comparing to this travel time to the banana station and the cost of the pallet, one pallet space over the full vertical height of the room. Right.
Okay. So,
and it's a simple calculation.
Yes. No, it's not so simple. It's not so simple, but it's a doable calculation. And if we simply look at productivity, having the bananas on the pallet would beat by a good margin having the bananas in the goods to person system.
Well, you give me two numbers. What's a number of seconds to reach banana station, and what's the cost of one pallet space? And I can tell you, is it beating? But it depends on these two numbers. It's not given that it will always beat.
Yes. So,
right? If the banana station is 6 seconds away, not necessarily it beats the automation system.
If you include the decanting process, probably it does. We had to go through this kind of calculation very often with customers, and it's one of the reasons why we came up. When I say we, that's my old company.
Okay.
We came up with certain system design decisions, and the customers we worked with, they were, let's say, these guys knew what they were doing. They were top of the game companies, and they ran these numbers up and down and did their productivity calculations. And I learned a ton from them, because this is not the way we thought about these things traditionally as a warehouse automation company. We never thought, we never did very detailed productivity calculations. But when you work with online supermarkets, you had an online supermarket, you ran one for a couple of years, so you know exactly what I'm talking about. You look at productivity numbers all the time, because you need
all the time, every day. Yes.
And so we ran this calculation very often, and we figured that if you have like 24 SKUs outside the automated system, you probably benefit in terms of labor productivity. Now, you're saying one very important thing, and that's the cost of the pallet location on the floor and the space above the pallet location. Now, one of the things that's almost never considered is multi-factor productivity. We talk about investment cost, and we talk about labor productivity and labor cost, but we almost never pour all the different cost factors into one productivity factor, into one productivity number, which we would call multi-factor productivity. And because we don't do this, we almost never know exactly how well an investment pays off, and if having this system a little larger or a little smaller, how that changes our business case. Because the multi-factor productivity would include the cost for the automated system.
That's why robotic as a service is so much easier for customers to calculate, because it's already you taking out of the equation this capex and opex play. Everything is opex, and therefore numbers are much easier to compare.
Yes, this makes sense. I understand this. It makes it much easier. Now, a couple of companies have been offering this for a while, and I've asked clients of mine if they have considered as a service models, for instance, for AGVs or for robots, picking robots, and they told me yes, they have. They have had several conversations with companies, with suppliers offering as a service payment models. But typically it was so expensive that after 3 or 4 years, it would have been cheaper to buy the system.
After hundreds of conversations with investors, I even know where this expense comes from. It's basically from, here's how it goes in practical reality. You come up with as a service model, and it is perceived as a new model to finance the equipment. And because you typically combine a new type of system and robotics as a service, or even if it's a new type of forklift, then the type of investors you go and talk to are more risk-inclined investors. They're not your traditional banks in the beginning.
Yes.
And so when you look to traditional, very kind of risk-inclined investors, VC guys, for them, it's a high risk, high payout game. So to be high payout, there should be very quick return on capital. So they expect 16 months payback period, 18 months. So, and that's your input, right? You take 16 months of payback period or 18 months of payback period, you insert into your real CapEx, because now CapEx is owned by vendor. And here you go, here are your prices. And but let me push back on all of that. Like, why the robot has to be paid back in 18 months? Why the robot that lasts for 5 years or for 10 years, why it's not equal to the automobile or to the forklift or to more traditional? Just because it's a new thing and people assume certain risk behind it. And that's where you get the prices. So therefore, on the CapEx side, for the vendor, you have to be several times better, cheaper, and then your OpEx, your as a service offering can be perceived as like good price.
Yeah.
Right. If you want still 18 months of payback period, but with time, as these options will fight through the clutter and will get into everyone's mind, and people will know that, okay, everything is reusable. A rack is reusable, grid is reusable, robots are reusable between the clients, between the installations, between any kind of move. Then this 16 months will go away, because it doesn't matter like how cool the robot is. It's just you're asking someone to pay monthly full CapEx plus production time divided by this 20 months, let's say, which is a big number.
Yeah. I really like as a service models for a couple of reasons. One of the reasons I like it is that it creates an incentive for the company offering it to improve the system.
100%. I agree totally.
So and that is something that is absolutely missing in so many areas.
With one caveat, you have to say as a service model with the zero maintenance fee.
Yes, exactly. Yes,
because
so repairs and maintenance are
included, and the maintenance is huge, then it's
true.
There's no.
I mean, imagine. I mean, this is currently happening, but it didn't exist for decades, like for 150 years actually. Imagine you would lease a car and everything is all in, which now exists, right? So there's a couple of car companies that are offering car subscription models, but it didn't exist until 5 years ago.
Well, so let me push back a little bit here. When who was that? James Watt, who invented one. I remember that some of the inventors of combustion engine, right? They have to price their system as a service and compare this to horsepower, for example, to remove water from coal mines.
Well, this is nice.
Because nobody understood their system. Like, we are in the same position as 150, 170 years ago. Nobody understands what your bloody automation is about. So therefore, the easiest calculation is to compare to what you have at the moment. People are pumping water out of the coal mines using horses.
Right.
So that's why you just express your price in the horsepower, and you say, look, my horsepower is less expensive than your horsepower.
That's a very good point. You know, it's so funny how we're going full circle. Also, like 150 years ago, electricity is becoming a luxury good. So, at least in Germany. So there's a lot of similarities. Also, we are driving electric cars again.
Yeah.
What an irony. Anyway, so what I wanted to say is, imagine, you know, for automobiles, we have so many crappy cars on the road, like cars that break all the time. I mean, there are car makers who are notorious for building broken cars, like including all American car makers except for Tesla. And we wouldn't have that if we would have had for many years basically flat rate models for cars. And imagine you're keeping your car for 5, 6, 10 years. and all repairs, all maintenance is on the car maker. Or maybe you don't have to keep the car, but the car's lifetime, productive lifetime, with some owner is 10 years, 15 years. And the company would have to make sure the car is running. Oh boy, how much better would cars be? How much more reliable would cars be than they are today? And the same is true for warehouse automation. I mean, I know of companies who installed really expensive systems and they ripped them out of the building like less than 10 years later because the maintenance cost and the repair cost was so high.
Yeah.
And that's just something that, if you think about it, it's totally crazy. They've just, if at all, they've just reached return on investment.
Yeah.
If at all, it's not clear because the repair and maintenance cost was so high. And then they're ripping out the system to replace it with something else.
Yeah. That's why very early on in our journey, we said that in our architecture, there will be absolutely no complexity, no sophistication that is bolted to the floor. So anything that is bolted to the floor cannot break. It's basically static parts. There is no memory, no electricity, nothing there. And everything that can break should be mobile. And the only thing that can break is a robot, and it's mobile. It's 45 kilos, and basically 2 people can package it and send it over back to maintenance facility. Even with the car, there are very few breaks that require a maintenance vehicle coming, right, to the car. But most of the breaks, you are coming and something is fixed, and most of the things are preventative.
Yeah, that's right.
But you have a capability to come to a service station on your own. With with old automation, it's not like that, right? You don't have any capability to come on your own to the service. It's a technician who have to arrive even for preventative maintenance.
And the continuation of your business depends on it in many cases, right? I mean, you can't ship if your warehouse is standing still. I mean, that's a problem, right?
Yeah.
But for you as a startup, for Instock as a startup, doesn't the as a service model create quite some challenges on the balance sheet side of things?
Oh, it does. But again, the clients, they also have the same question. They also have to get money somewhere, right, to finance CapEx. And we are in the new reality, right? Money are not cheap. But the question is then, if we look at it purely from efficiency standpoint, why is it better to, for example, for us to take debt rather than for mid-sized client to take debt to buy the system with the upfront cost?
It's a good question. Why is it?
It is a question of who is in a better position to calculate risks, because whoever is calculate risks better will get a better ROI eventually, right? If we assume, like, if we compare, okay, Instock is having that financing, and let's say we compare it to Kroger or Walmart or even AutoStore, of course, they have much cheaper money available, right? But if we compare to mid-size client, we are better calculating risks of our own system than our clients, because we know inherently, right? We know how to redeploy it. We know that even if a client churns, we can disassemble everything and install the client next door. All of that is our inherent knowledge. We try to kind of relay it and communicate it, but again, you have to multiply by coefficient how effective our communication is. So therefore, people don't have that ability, and therefore it's better for us to take CapEx rather than for our clients to take CapEx. Yes, it is challenging. You're totally right. It is super challenging now.
Well, this is very interesting.
But it makes sense.
So you're lowering the threshold to automation for your clients because you are able to remove that financing obstacle from them, and you're removing the risk from them. And of course, it's a risky thing for you because you're just you're just getting started.
Correct.
Yeah.
Correct. We feel ourselves like this is a system from the future, right? And it's
certainly looks that part.
it's not non-trivial to explain. So it's a little bit like you're pumping out water from a coal mine using horses, and I come to you and say, hey, here is my combustion engine, and you say, what? Combustion what? I say like, okay, forget it. Just I will pump out water from the same coal mine that you have with like 1 horsepower will be better priced, period. So that's a thing that we want to achieve. First, it's a much easier calculation for you. It removes and reduces risk for you as a client. And it makes sense because we can calculate risk better. It will always be like that. You may ask a question, okay, why later automobiles are been sold rather than rented? Why Henry Ford was selling automobiles and not establishing a leasing company? Well, I'm not a specialist in the history of that market, but so I don't have maybe a good answer for that. But
it was good
maybe,
for him, I guess, because it's if people are buying it, it's much easier to sell
exactly.
it.
He achieved certain threshold in price, so he dropped the price so significantly that a single family, so many families were able to buy a vehicle.
Exactly. Exactly.
And so that formula
his own
worked
workers were able to buy their own vehicles, which they built in the factory, which is one of the things that he wanted them to be able to. Right?
Yeah. And so it made a full circle, and I think automation will also make a full circle, and it will get to a situation when it's like, I don't know the proportion between purchased automation and as a service automation, but what I will definitely know, and I'm confident in this part of the future, is that the moving parts of the automation will be serviced elsewhere, not on site. You will not send technician on site.
Why do you think that?
Well, because it's just much more effective, cheaper way to organize things. Let's take, like, we have a client, right? Let's say our client is in Toronto, and let's say we have a maintenance facility for robots in Detroit. What's the cost to send 45 kilos from Toronto to Detroit?
True, and that's not a long distance. That's not a long distance. So it's too much to drive there for like 1 day and back. But yeah, you're right. But typically you would have a service network, like you would have service points across the country, so the driving distance to any significant site.
That's what company. You take Otto Motors, right? Yeah. Probably one of the best example. They have incredible service network, but that service network is something like more than 2,000 technicians.
Yeah, it's a lot of people on the payroll. Yeah.
And not necessarily on payroll. Those can be contractors, right? Certified contractors. So they, for example, if you have a robot that is 500 kilos, obviously clients will not be able to ship it by themselves.
You're right. You have a pooling effect if you can centralize the maintenance and repair functionality. Correct. Right? And so it's much more efficient than having 1,000 people distributed across the country.
Extreme example, you bought Roomba, right? Your Roomba went rogue. It is not working. Yeah. Are you going to call technician to fix your Roomba on site, or you're gonna take the Roomba and bring somewhere, or you will throw it away?
Good point. Yeah. Good point. Yeah. True. Talking about systems from the future, can you pull up a picture of the Instock system? Yeah, pull up a picture of the future.
Sure.
And so we can.
If you don't like one picture, I have another one for you.
Yeah, I'm sure you have a second one. so that we could explain the function and principle of Instock, because if you just visit your website, on instock.com, then you see the video and you see little robots driving up the wall and under the ceiling, and then you think, oh, all right, so this is very different than all the warehouse automation technology that I've seen before. And a lot of people I talk to, because once you came out of the stealth mode, which is something else we should maybe briefly explain why you did this. A lot of people have said, well, this looks complicated, this looks error prone, how can this go right? So maybe we can start by going through the function principle, and then maybe you can address some of the concerns that I've just mentioned.
Yeah, sure. So
maybe you can pull up a picture of the system so it's easier to understand.
You mean like to share a screen?
Yeah, maybe just for a brief moment.
Sure.
If it's convenient. If not, then
it is convenient. Let me just so I think the best would be if I just launch the video for a sec, because the website everybody can see, but
so there we have the future.
Yeah, so you have the robot that drives on a floor, on a ceiling, and vertical walls, and it is using this curved part of the, we call it ramp to a vertical wall, right, to position itself. So the drive over the vertical wall is used only to position robots on proper levels. So you need a certain number of robots at certain moment of time at every level. And within like operation, 1 cycle, 2 cycle, 3 cycles, the number of robots on a level will not change, right? So they will, let's say there will be 3 robots on level 4 on a ceiling, and it will stay like that for 10 minutes, and then they will rebalance itself. So they use this vertical drive not too often. So the main cycle is a robot picks up a bin from above. There are stacks of bins. Robot moves bin along the ceiling, and then bin goes down through vertical shaft, we call them bin shafts, to a robot that is on level 1 or level 2. And it's the same robot, same type of robot, but it's moving now bin on its back while moving on the floor to present to operator, to associate. So people are interfacing with robots only when they are driving on the floor. You have basically access to bin when robot, and you never have to touch a bin or a robot when it's on the ceiling, right? So this is a component that is behind the barrier, so to say.
Yeah.
So again, here you see the workstation, and it's one of the implementations of the workstation. Workstation in our case is just a fixture. It's a part of the furniture. It's a way how robot can drive and present the bins to you conveniently. In this case, you see 4 channels. So you have access to 4 channels, and you're picking out of the bin and you're putting into some other external container, wherever that is.
Yeah, and that could be on a conveyor or something, right?
Conveyor, dolly, whatever.
HEV,
you have a different HEV for sure. So
are you planning on utilizing those robots also outside the storage cube? Is that
in the future? Yes.
In the future.
In the future, because again, the form factor of the robot and its kinematics, it allows us to drive outside of the grid without any changes to hardware. It's purely a software update that will allow us to drive. Right now, the robots and grid, they have very simple, flexible connection interface, right? The grid is very loosely coupled to a robot. So you see, it's a pretty big wheels on a surface, and that surface not necessarily even is flat. So we can allow ridges, gaps, steps.
The tires look very rugged,
even on the ceiling.
So yeah, I can imagine.
Yeah. So now back to your questions: why it is designed this way, rather than some other way. From the years of our experience, we came to certain conviction what should be the priorities for 3-dimensional goods-to-person system. And the number 1 priority should be that everything, you have to design everything in such a way that the grid, the way you organize space for storage, is very cheap, static, and cannot break. So this was number 1. Like, you want grid that is absolutely simple, stupid, flexible, and it's from very simple components. And that's what you see here, right? You see a sandwich panel, which is a 21 millimeter of plywood and 3 millimeter of steel it's a regular steel. It is flat. There are hundreds of shops that can cut it for you. Any laser cutter that can cut 3mm metal can produce this part of the panel.
Yeah,
you
okay.
see column, which is like a regular pipe, and you see connector, which is the sort of custom-made element to connect the two sandwich panels and columns. And these are the complete set. These are the three elements that create the main body of the system. Of course, there are other elements, bracings, protective barrier, and so on. But these three are a major part of the cost, and it's simple and cheap.
Right.
Another thing that you see here is that the grid does not predefine where the storage locations are.
Yes.
Which is an important difference from others.
True, although if you're always using the same shape bins,
you still may want to change storage location layout.
Why?
Because again, remember the previous, like 30 minutes ago, we were speaking that you can't predict how your business will evolve exactly, especially in a micro scenario. So you may need a different ratio between density and throughput. And also when you
would like basically reallocate some of the space available from driveways
Correct.
to storage. Yeah. Okay,
exactly.
So I understand this. Okay,
we can add more workstations or fewer subtracts workstations, right? But the same space is used for storage and driving, and actually, I mean, all of that is modeled. And I don't have to, one sec. So I don't have to, you don't have to take my word for granted. Like if you are a client and let's say you say, what it will be like if I will have not 2 workstations here, but let's say 4 workstations. And we will say you exactly in numbers. We will tell you, well, the storage density will go down by 10%. So you will have, for example, storage density, not 25 full fairly calculated percent, but let's say 15. Yeah. But you will have much more throughput capacity.
If we're looking at this picture, looking at the CAD model that we see here, can I ask, what is your fire safety concept? Because this looks like you would probably would have sprinkling below each of the
we have sprinklers on every level, because again, people don't realize how much of the constraints are coming purely from the fire code, independently from how you organize your system. So you're above 12 feet, you're high pile storage. So you need
but in this case
sprinklers.
it makes sense, right? So because you can't sprinkle through the intermediate ceilings. So
and then you will ask, okay, but how AutoStore can be 17 feet? Right, they have 16 beans, for example, and it's the same not have in-rack sprinklers. And the answer is, well, first of all, they have, it's a single stack, so they paid for this capability in the constraint that it must be a single stack, so they have to go and do the significant digging. Right, so if you have multiple stacks, you already have to have something in between them to suppress the fire.
I don't think I don't think they had fire safety in mind when they designed AutoStore 20-something years ago. I think it just emerged. I think the design emerged out of.
They got through it, right?
I'm really purely guessing here, but I think they just threw something at the wall and it sticked, and then so they played around with that.
They made full-scale fire tests. So, but again, there are
they
two.
Did, but 25 years ago.
Yeah, of course. Then it was not on their mind. But nowadays, it's. I mean, and you know how the industry works a little bit, right? Like one thing is fire recommendations of an FBA, and another thing is like insurance companies. Like if you are not insured by FM Global, then. Well,
yes,
and
they do have their fair share
roadmap
of headaches with fire safety these days because of the 2 fires that broke out at Ocado. to my knowledge, there's never been an auto store system that caught fire in the wild. There have been controlled burnings of auto store systems for testing reasons, but I think they never had a system in a live system that burned down.
Yeah, good for them.
Good for them. Yes.
But just to emphasize this, auto store didn't have fires, but insurance companies are looking at the market holistically. They say, oh, auto store had 2 or 3 fires, right? I don't know exactly, but this means those cube systems, they can catch a fire. Yes. Therefore, insurance premium for all of the cube systems should be higher, and therefore everybody will pay for Ocado fires in one way or another.
Yes, it's very painful for large parts of the markets. Also, I learned 2 weeks ago that insurance companies aren't making money in the warehousing industry because the cost for business interruption is so high that they're basically losing money on average, with their policies. And so one of the things we can expect is that the insurance premiums will go up even more. The other problem is they don't understand what they're actually insuring. They understand what they're insuring against, but they don't understand the technology they're insuring. So, for them, as you said, Ocado AutoStore is any block storage system. And so
they have to extrapolate, right? Like they're not customer, they won't install for just the sake of playing, but they will go, I think they will go into every installation where there was a fire, and will investigate what part of the robotics actually caused. And obviously the usual suspects are lithium-ion batteries, the way you charge them, how the contacts are organized, like the overheating.
Yes. Yeah, I've been getting familiar with fire safety a bit more in recent weeks. It's one of those topics that I never cared for. I was always happy if somebody
else, is influencing so much everything in design.
Take care of that. Yes, and that's important, and but it's something that nobody enjoys doing, and so the level of knowledge tends to be limited on part of the planning engineers.
We have to invent some kind of drug to inject into people so they enjoy more fire suppression, because the consequences are dire, right? Like nobody, automation world, let's say people there do not enjoy fire system, and that's why there is some disconnect between the fire guys and the automation people, and they're like, we don't like we do like each other, but not
because we have to. It's an arranged marriage.
Exactly. Yeah. So to finish the answer to your question, so the first priority should be to make grid very flexible, very static. It cannot break. It's eternal and cheap. And the second is the hardware complexity of the robot. It is limited. And only the third one is a software complexity. So here is a difference between us and many other companies. Other companies, they have certain mindset. It's either hardware or software prevailing.
Yes.
Right.
And
so for them,
in the old companies, in the old-fashioned companies, it's almost exclusively hardware. They do not understand software.
So it's a perception of complexity. Of course, it's like when you have a hammer, everything looks like a nail, right? So a complexity of hammer plus a nail for you is very low. But we look at this from a complexity, obviously, and we have both software and hardware co-founders, but we also look at this from scalability perspective. The software is much, much, much better scalable, and in both design and you may say manufacturing, right? Manufacturing is zero. It's not zero. You have to distribute.
The replication cost is low, but
replication is zero. But you have to distribute and deploy carefully, and those people who can do it carefully and know how to do it are costly. So, but in any case, it is several orders of magnitude better from a scalability perspective. Not several, like I said, 2 orders of magnitude. So 100 times better to put complexity into software rather than to hardware. And so that's what we did. We sucked out everything from the hardware and put it into software. Everything is possible from
for an IT layman like myself. this, this sounds convincing at first.
Yeah.
Now, having worked in the industry, one of the things that I've learned is that projects typically, like in the old-fashioned companies, and the incumbent companies, projects fail not because of hardware, but because of software. Because
Really?
they know their stuff. They know how to build a stacker crane, and they know how to build a conveyor. They know how to build a shuttle. At least some of them do. Most of them do. That's, whether you buy a shuttle from Knapp or TGW or Dematic or SSI or Swisslog, doesn't really matter. There will be some differences in the details, but they're all good. Right? There's no shuttle system that is really bad, and these are all good companies. But the software is such a pain, and a system that is comparatively simple, or that seems comparatively simple, like a shuttle system, you would think the IT part, they have, a company like Knapp or a company like SSI, they have built dozens of shuttle systems. You would think that the IT part must be simple because they have done it before.
It's not simple. Yeah,
it's not simple. It's a major problem, and that is eating their margin. This is delaying the projects. This is just
absolutely. I mean, I totally agree. But
a friend of mine,
it's a question what do you want to solve, right?
Yeah, a friend of mine sold a deep freeze warehouse in the US a couple of years ago, and he told me that story. And I'm not going to say which company that was and who the customer is, but so we should be safe. He sold the system with an estimated IT effort of 3,000 hours. Was it? No, sorry, 7,000 hours. 7,000 hours. Now, 7,000 hours.
It's pretty significant. It's not small.
To you and to me, this sounds like a big number, but 7,000 hours is like nothing. Okay, so once they've signed the contract with the customer, and of course the contract price was based on the 7,000 hour estimation of IT effort.
Yeah.
Once they signed the contract with the customer, some middle manager or some senior guy came to his office and said, "Hey, yeah, we can't deal with these 7,000 hours. Probably we need 13,000." Okay, so we have a cost overrun right there. Now that's 5 years ago, or 4 years ago. Currently, the number of hours they've put into the project, you want to make a guess?
Like 50,000 already.
130,000, he told me. And the project is still not running.
Yeah.
Can you imagine this? I mean, we're talking about, we're calculating in terms of IT hours, but we could be talking about IT lives. I mean, there are several people who would do nothing else from the time they graduate until they retire. Working on this, and that's crazy.
I can imagine how where it comes from.
It's
basically where you have hardware, you have WMS, you have so many layers, and for those layers to work efficiently, you need a very good full stack people who can traverse and understand the layers top down and bottom up. And you don't have too many of those good people who can actually traverse and understand top down and bottom up. And therefore, in the software world, if you work with people who don't have experience, don't understand, then it's very easy to produce movement, right? Activity, but it's very hard to produce actual working system. So that's why you have to be very, very careful. Like it may be 1,300,000 hours, right? It's not the question of quantity, it's a question of quality very often.
Definitely, and it's a question of legacy systems that you have to work with because they're not prepared for the kind of processes that you want to implement in the warehouse. And the software topic has been so painful all the time. I mean, I would say it's the number one pain point and the number one risk factor for several of the automation companies that exist today, because they do not come from the software world, but they need
but they need good software people for sure.
They need, and it's like German automotive companies. They knew how to build a car until the 1990s, and then the qualities they had were not needed to the same extent. Now they need to be software companies, but they don't have software engineers. They don't have
software is eating the world, and it came to automation world, and there is no way out. Like you one of the two. As a old-fashioned company, or let's say traditional, you're either getting good software people somehow for any money, they have to be on board, or you will be displaced with time by younger companies. That's it.
Well, that requires senior management that actually understands the complexity of software, because the kind of comments I've heard from senior managers was something like, "Oh yeah, the software, that's not the problem. We can deal with that." So because clearly they did not have any idea.
Not enough scars.
They should have had, but apparently they did not. They don't learn.
Yeah, it will be more and more obvious with time in the coming 2, 3, 4 years that without being software company first, or let's say not even first, without having software as a very significant part of your design, you eventually will lose. And here is how the German, Austrian, and the European companies, there is a ratio. There are very many companies that are family owned.
Yes.
Right. And in the US, much more companies are public.
Yes.
And here is a difference between Europe and the US, in my humble opinion. Maybe I'm wrong. It seems to me that public opinion is less forgiving. So the moment it is obvious that this company is losing eventually, nobody waits for it to lose, right? The stock price tanks the next second.
Yes.
And that's why US companies who are publicly traded just get out of their way to present themselves that they're future-proof, even though half of it is complete bullshit.
Yes.
Like this is just an image they want to present. They're not even close to being so future-proof as they want to be want to be perceived.
Which, by the way, is
whereas Europeans,
I think companies adopted microfulfillment centers just to signal to shareholders that they're future-proof. I think that was the dominant.
No comments from me, but let's say you're not totally wrong on this one. Yeah, absolutely.
Can I ask you something else? You did something that's very unusual. You worked in stealth mode for the first couple of years with Instock.
3 years, yeah.
For the first 3 years. Can you explain why you did that?
Versus
having marketing material from day one before you had a product like many of your competitors.
I can't claim this is a better way, especially it depends on like what's the market climate at the moment, right? You may be better off by running around with 3 slides and raising $100 million on some crazy valuation when it's a boom time.
Yes, like
you may be better off with that strategy, right? Again, no comments on the players, but it's just what type of person you are. Like, I know how it's done. I'm just not enjoying selling complete vapor, because I think selling vapor and then trying to go back to design and engineering and try to say, hey, we now have the money, let's now build it. It doesn't work that way, because when you have the money, your mindset changes. Really. I'm not saying you have to be poor to be a good painter, right? But there is a little bit, there's something in your design process that you think much more efficiently, and you choose different kinds of solutions when you're constrained.
Yes.
And so we were constrained in the first 3 years, and I think like, okay, if we would counterfactual thinking, like if we would have raised money in 2020, would we came up with the same solution? I think we would be bankrupt by now already.
Oh, that's, by the way, that's a good point. When did you come up with the design of the system? Because apparently you didn't do this from day one.
Yeah, of course, various pieces came at various moments. So we decided that the robot will move using magnets. It's part of its kinematics model, right? And the ferromagnetic surfaces, roughly by August 2020, so very quickly, when we built the first prototypes, and there were no software control, so we were driving them with joysticks. But we saw that they can do all of the tricks. So we were convinced. Basically, we thought about this as a usual pattern of thought process. You make a table with all the risks. You do times the implication of the risk, and you sort by this third column, which is the multiplication of how high the risk with the implication impact factor. And so, of course, like if we don't have kinematics of the robot, we have nothing. So we wanted very cheap grid, and we understood that we can't create this cheap grid using just ferromagnetic surfaces, but we needed kinematics of the robot to work. As soon as we saw by driving joystick that it does work, we now started to think about, okay, software, how to control localization. The first localization was purely built for demo purposes, for fundraising, was based on the QR codes and the industrial QR code reader. So we covered all of the surfaces in QR codes, which is another piece of technology we can patent probably, how to print and stick huge QR code labels. But you can get an incredibly good training material for even if you drive using like AI, because you have. So, for example, you can the Keyence QR code readers that we were using, you can go and buy used one for $500. So for $500, you are getting sub-millimeter precision of your localization, 30 frames per second coming out from the Keyence.
Can I pause you for a second? I need to close a window.
Sure.
The rain is starting. Give me a second. So Keyence QR code readers you can buy for 500 euros used ones, and
yeah, and that was ideal localization for demo purposes. And then we always knew that we had to change localization. So that Keyence idea worked. We postponed the problem, and then we came with this localization that you have seen, that are fiducials on the columns. Much cheaper, better, but more sophisticated from a software perspective again. Problem. And mostly what we've been solving in the past 2 years are polishing the hardware, so improving the kinematics of the robot, but in many minor ways. So the diameter of the wheel has changed, the position of the magnet, how the magnet looks like, how the control of the magnet looks like. We changed from like USB to CAN bus, the usual progression, right? Like you don't do things with USB ever in production. It was well understood. And and the last year, it's mostly about software, navigation, localization, optimization of the like cloud to robot interaction and so on.
Now, you've been in the warehouse automation business for a couple of years. First on I guess, at least on the client side, at least on the part of interested people, and then.
So I wanted to buy Kiva Systems as a solution in 2012.
Right. Okay, so you were very early.
But like I started conversation with them a couple of weeks prior to announcement that they're acquired as a company by Amazon. But then, of course, as in role of CTO of Takeoff, I went through all of this journey of first getting in partnership with Knapp and so on.
Yes. What has been your biggest surprise in the warehouse automation market? Is there anything that blew your mind? Anything that you did not expect when you started out?
Yeah, I was impressed how backward it is in terms of software. Really, it was a little bit of a like, no offense, right? The systems are great, but I just only when I installed the first one, I realized how basically from the 90s, 80s, these things are. So you have PLCs, right? Where on earth you have PLCs these days? You have so many various tiny hardware pieces that are bolted to the system, to the integral part of the system, that do some push, pull, roll. And by the way, all of those pieces are producing noise. That was another my impression.
And
how noisy
and heat.
How noisy that thing is, right? Heat, I haven't felt that much because I never was paying the bill for the AC, but probably clients have felt it, right? But the noise you clearly feel when you are in the room. And so, and the system works, right? Those shuttle system work, but I didn't feel like I'm enjoying working with them. Absolutely not. Like I felt like maybe if you were giving, if I would give a mainframe computer to you right now, you have your laptop, right? You're enjoying using your laptop, and now here is the new beautiful mainframe. Like, please use it. It's cumbersome. You can't reinstall it. You can't move it. There is no simulator. At least, like, I never got the decent simulator and so on. Overall, again, okay, good system, but I was not enjoying working with it. And with robots, a totally different class of challenges, but it is much more from the new software world, right? So you are fighting with, I don't know, Linux driver to acquire images from camera faster. Different thing, right? You are saving some watts and milliwatts of the thing that is consumed by computer vision. You want your thing to run on the cheaper, smaller, more energy efficient computing platform. For example, we are using Raspberry Pi compute modules, which is like, we deliberately have chosen this platform just because of how widespread the support of and how much software there is for that platform. But it demands from you to be very efficient with your algorithms. So we have, for example, one Raspberry Pi computation model producing 2 video streams from 2 cameras, 30 frames per second. And with all of this, Raspberry Pi is not overheating, which is a challenge, right? You have to program very carefully and do like all of the optimization. Like you cannot just take OpenCV and plug it in and say like, oh, with regular functions from OpenCV with all of the C++, you get the temperature you need. No, you have to optimize further down, but
now,
different class of challenges. I enjoy them more.
Your company is one of the few warehouse automation companies that are headquartered in the Silicon Valley. Is it Silicon Valley?
Well, it is Silicon Valley, but look, the distribution, we have people in here in the Bay Area, in Bratislava, Slovakia, and in Ukraine. To say we are, yes, we are headquartered.
Okay, so your company registered.
We are very distributed
in the Silicon Valley.
No, we are here, right? So I'm talking to you from St. Carlos, Belmont.
In your opinion, does that make a difference to the way that you do your business?
Much less than it was 5 or 10 years before, because COVID changed it so much. Now it's much flatter world. Now everybody is speaking remotely, and it's totally fine to sit, I don't know, in Croatia and raise millions of dollars from investors in the US. So for us, choice of Bay Area, California was less of where business should be. Most of the clients are actually east of Mississippi, right? But it's more like a personal choice.
Yeah. So it's not been access to software engineers that was driving the decision?
No, we have 0 software engineers in the US. It's not
interesting.
Like, yeah, I mean,
you would think that's the main reason why people go to the Silicon Valley, because you find competence, right? But it's software competence.
Maybe, but it's again, it's here you're talking to one individual. For me, I have access to talent because I was working with engineers all my life. Like on multiple continents and many companies. And so for me to find software people, a very good, very talented one, and kind of encourages them to work on challenging problem, it's not a big thing. For others, of course, it's a hard problem to solve. But if I go, like, I can do the same with engineers in Silicon Valley, just will be much, much more expensive.
Yes.
So
Yes.
here I'm competing with like those big tech who still want you to be somewhere nearby.
And you know, I do think there's some value in sharing an office. There's the cultural component that plays a very important role in people's lives and people's work life, and also in people's performance and in the loyalty to the company. So it was very interesting to see that during COVID, there have been, you know, the typical very smart people that you find on LinkedIn that were all predicting that we will never go back to the office because we don't need to. And now that we've tried it out and it worked, nobody will ever need an office again. And it was obvious to me from the beginning that they are very wrong, because they were underestimating the human desire for having shared experience in the same physical space, which is an important element of life for many people. I mean, at least, you know, I can talk about myself. When I'm just at home all the time, I get terribly bored. I need to see people from time to time.
You mean shared experience more than Zoom and Google Meet?
Yes,
right?
yes.
Above Zoom and Google Meet.
Like a coffee machine. You need to meet at the coffee machine, and not intentionally, but coincidentally. And then a lot of interesting conversations emerge from that, and just from being in the same space, being in the same office, working on hard problems, either independently because you work on independent projects, or working on the same project. That's a very different life to me than being isolated at home, staring at 3 screens, running a data analysis, and then sending it over to somebody else. You know?
Absolutely. So I think now we have a more diverse world in terms of, like, everybody can find the formula that works for them. For many people, what you say is important. You just find yourself more productive if you're even one day in the office with other your colleagues solving problems, or discussing them. Because again, Google, I think Zoom and Meet, like the video conference, was now with us forever. Right? You're not gonna take this out.
No.
But you are just enjoying more when you can combine those things.
Yes, exactly.
When you must be in the office 5 days a week and you don't like the office, believe me, that's not the ideal for productivity.
Exactly. I mean, the mix is great, and the possibility of individuals to make their own choice where they want to work and from where they work best.
Yeah, for companies,
really,
it's a
really
new
important.
layer of challenge, how to filter out those who are not honest, right? Because but I think it's a solvable problem.
It boils down to bad management, because if you give people work to do, you will notice if they don't do the work. But if you keep people busy for no good reason, and then they work from home and they find ways of not being busy with unimportant tasks, and then management doesn't like that, then that's not a problem of having dishonest people, but that's a problem of having stupid management. And I think in many places that's exactly what happened. People were busy with nonsense, or, you know, they didn't have ownership, or they didn't feel ownership for the work they were doing, so they didn't want to do the work they were doing. And so in the moment they get out of sight, out of control of, you know, the management, they stop doing what they don't necessarily have to do. And I guess that was some of the early misconceptions about home office, that people wouldn't work. But they will work if they have work to do, if it's important work that they enjoy, independent of where they are and if somebody's watching or not.
In other words, you're saying it's very easy from a management perspective to invent work that says, just come to the office, you must be in the office. That's a very easy task to create, right?
Yes, I mean, honestly, we are living in a time where there are a lot of companies that are well off and that have lots of money, as indicated by the number of useless jobs that we also create in companies. I mean, you know, we don't need to talk about diversity officers and things like this, but, you know, the number of jobs that are not value adding, not value creating in companies has been increasing in many places. So
how have you still in Germany? I'm surprised. Like with this way of thinking, you have to be somewhere in the conservative part of the US.
Well, let me tell you.
You can get in trouble, I guess, in Europe.
No, we have it's a pretty diverse place. So there are people with who have different viewpoints, but I have to say that I think a lot of people are afraid of speaking out and being honest about a lot of the nonsense that's going on in the economy.
Sure.
And not risking to be fired by a private corporation or especially by a public company that need to maintain a certain reputation is great. To put it mildly.
Yeah, and this kind of, when people hold to job and when managers need to have a certain number of people just to prove like their importance, that's horrible. That's not efficient. And
can I ask you something
should
else?
Go.
What kind of technology or technological advancement, in your opinion, would be a game changer in the warehouse automation industry? Now you've seen some backwards technology, and you pointed out that software is very 1990s. And is there any particular technology that you would hope to become more established in the warehouse automation industry, or that would make your life much easier? Is there anything that comes to mind?
Well, I think it goes back to some of the technological choices we've made. So you look at the wheels that the robot has. You think, okay, first of all, we piggyback on the scooter revolution. There were so many scooter companies that were buying so many wheels. So you have in Asia so many wheel manufacturers, new vendors. And the wheels we have, it's not the wheel that you can easily get, and it's not the wheel that you would typically put in a scooter, but it's produced by the same company that's producing wheels for scooters. And it's very same, it's a hub wheel, but it's a hub wheel with such an encoder that you can track very small angles of its movement. So even when you linearly moved like a couple of millimeters, this. We would not be able to create our robot if that wheel would not exist.
Mm-hmm.
We would not create our own wheel. Sorry.
That's interesting. Something that you wouldn't. A wheel is not the first thing I would think of.
Yeah.
That is such
so
an
the hub wheel
component.
With the control of the hub wheel, and then the control of hub wheel. It's like why those BLDC motors are penetrating only now. It's because the software is there to control them. 20 years ago, it was super hard. You had to be, I don't know, TGW maybe, to develop your own controller to control the wheel. Like the regular company wouldn't be able to do this. So nowadays you have open source hardware. The controller we kind of cloned from is called VESC, Weather Electronic Speed Control, and that's an example like what have progressed significantly. Another is neodymium magnets, right? So we wouldn't invent neodymium magnets. We are not doing those alloys, or we're not mining neodymium. So this is another thing that enabled. And I think this control of the motors, and in our case, neodymium magnets, that's the improvements that you're looking for. And the software will come. I'm pretty sure one way or another the software comes. There is a software, there is another issue that there could be a brief moment when all of those systems are applicable, and then you have some really bad-ass AI and bipedal robots that solves everything. It's not fantasy.
Yeah, let's talk about AI just for a brief moment, because I'm a bit fed up with that topic, but because it just here
pay the price to modernity, you have to talk about it.
Yes, exactly. So let's do it. My view has been that in the warehouse space, there's very little use of AI. And the one application that I have in mind for AI is basically object recognition. So, you're taking a picture for a robot, for picking robot, you need to identify an object.
Yeah.
These are machine learning algorithms.
Yeah. They can be, but they may also not be machine learning.
Okay. So they can be.
Yeah.
What other applications of AI do you see in warehouse automation? Do you see any?
I see that it may play a significant role soon in robotics.
In what way?
In a sense that you want more and more universal robots. It's like two ways of thinking about this. From one side, you may say, oh, I will do very specialized robots, and I will try to produce them massively, and I will try to make them as cheap as possible. But there will be many specialized types.
Yes.
And from the other hand, you can say, oh, I want universal robots that can operate in the free, open environment.
Yes.
And of course, but the curves of these two different approaches are like that. The first curve is, imagine logarithm, and the second curve, imagine exponential, right? So in terms of efficiency. So of course, for anything universal, you have to invest much higher capital. So it would cost Tesla,
it's inefficient. It's inefficient. It's
flexible, $100 billion to come up with level 5, if not like, I don't know, $200 billion at the end of the day. I know how much money was burned by Waymo by now. I don't know, but I think it's already in many, many dozens of billions of dollars. So it is a very expensive project. But once it is done, and all of the complexities in software, some maybe still in hardware, it's very dangerous for every other type of tech.
Do you see this happening anytime in the next 10 years?
10? Yes, absolutely, for sure.
Really?
Yeah.
Oh, okay.
10 years for sure. Like you take a bipedal robot of Elon Musk that I'm assuming the marketing videos are 100x better than what's in the lab, but even if they're 50 times better than what's in the lab. You take guys like Agility Robots, you take 20 other bipedal robotic companies. In 10 years, it will happen. I don't know who will that company be. Like most likely there will be the early wave that will fail. But I have no doubt that it will happen. And then, like, if you are a pension fund somewhere, I don't know, in Norway, and you put all of your money into AutoStore, I would be very afraid. Because if you're thinking 20 years ahead, there could be trouble in 7, 8 years.
Yeah. It's a very opaque field in a way, because it's so difficult to understand to anybody. I mean, even for technical people, it's difficult to understand. But I mean, think about investors who do not have tech background. How can you understand the true potential of robots in warehouse automation? And my point of view, and I'm a very, let's say, I'm conservative in this respect. For a lot of solutions, it's not enough if it's 80% good or 90% good.
Yeah,
it needs to work always and 100% correct. And I believe that we can come a long way with manageable effort, like 80-20, right? So you invest, say, 100 billion euros, and then you get robots that can do a lot of stuff under certain conditions.
Yeah.
Making these things so good that they can do all the stuff, and the conditions are much more loosely defined, will take so much effort that it's not going to happen in the next 25 years. That's been my estimate, and I might be totally wrong because I'm a layman. I'm not a robotics engineer. I'm just observing what's happening on the market, and I see the everyday struggle with technology that's almost good, but not really.
It is hard to be right or wrong because it's inherently unpredictable. It depends on breakthroughs in research. And I mean, nobody can predict breakthroughs in research, but you have to be very aware that a couple of more breakthroughs, like backpropagation, like transformers, a couple of more breakthroughs, and it may kind of start to develop much faster. And this more universal type of robotics may appear as a very, very new player. But right now, you're right. So, but I wouldn't bet on that. Look, my position is agnostic. You don't have to bet.
Yes.
Only if you're in a VC world and you are investing in AI, you sort of have to bet on that. Okay, it will happen. Me and you, we don't have to bet. Like I don't have $10 billion to invest into that kind of R&D. And therefore, you may say that in a grand scheme of things, Instock is an incremental improvement. Even though when we're selling the system, it seems to me like I'm selling something from the deep future.
Well, that's a good, incremental improvement. I think, there's another warehouse automation tech company coming up like every couple of weeks at the moment, and
which is great.
It is great, but it seems to me like they are, if at all, they're providing some incremental improvement at a much higher complexity grade. So I wouldn't.
This is not great.
Exactly. I wouldn't want that. I would probably stick to some combination of, mature technology from incumbent.
Look, don't worry. The practical reality of nowadays is on your side, because as money gets more expensive, the world gets more into this incremental guaranteed improvement or semi-guaranteed, rather than into like, oh, let's invest $10 billion into something that
we've had this for the past 10 years, right? So
exactly. And you have love-hate relationship with this trend, because from one side, yes, you can invest into something really breakthrough. Everybody loves that when it works. But from another side, you have this love-hate, because back to your question, how VCs can make a choice. They make a choice on something that is called storytelling. I'm sorry, what is the storytelling? Your technical abilities or your research abilities and storytelling are almost orthogonal. Like these are not correlated properties of a human. So you have a bunch of people who are just liars. They are nice storytellers. And you technically cannot call them liars because they're speaking about the future. You cannot lie about the future. You can lie only about what's in your memory, which means what's in your past. You can lie about your intentions, right? But you have a bunch of really liars going around and telling that, oh my God, telling a nice story. And then VCs are investing that story. And then you look and you say, like, why this prick raised $100 million and made it so hard for everyone else, because now there's a whole class of capitalists sub-segment that think like, oh no, that idea doesn't work. Like we already invested 100 million, didn't work out.
Well, you must. I must say. You have to wonder about the decision-making process at VCs. I mean,
there's no better way.
the amount of money these companies put into completely nonsensical business models like GoPuff, like the entire Q-commerce industry, which was set up to fail from day one because it's so obviously not working, and there's no way it can be. They can make it work.
What is the Q-commerce industry?
Q-commerce, like GoPuff, Getir,
oh,
Gorillas.
Okay, I
those
see.
Guys.
Q-commerce. Well,
quick commerce.
Yeah, there was definitely an overstretch into the. And what is a little bit sad about that all quick commerce jazz is that people were repeating the same mistakes so many times, right? They weren't trying a new technological thing like failing. No, they
were picking potato chips in corner stores, and then they sent some dude on a bike to deliver that stuff. And then these companies labeled themselves tech companies because they were receiving their orders in an app.
Yeah.
I mean, how gullible can you be as an investor to invest in that kind of business and
We don't have to
expect
worry about that because now the
True. I mean, they
money-
must be doing something right. I have no money to invest, so I shouldn't judge them. But I mean, that's so
There's a
obviously
lot of money in the
nonsensical.
world, and you see the. And by the way, Berlin is one of the hotbeds, right, of high-tech investment. So
It used to be, yeah.
it used to be. What do you mean? It's not anymore.
Well, investment in what? In Q-commerce?
In high-tech,
In high tech. Also, I don't know. I don't know. It could be. Yeah, could be.
Because when I think about Europe, I think Berlin, Barcelona, Paris, London.
In that sequence, in that order.
My stereotype.
Okay.
Well, if I would have to put it in order, that would be probably London,
Yeah,
Berlin, and then Paris, Barcelona. I don't know, but
yeah. It's interesting, you know. There are places in the world where it seems like there is some investor at every corner, and there are other places where you can live for years or spend a lot of time without ever meeting one. You know, I lived in Norway, in Stavanger, for a while, and I got to know and still get to know so many investors who live in this tiny place, 100,000 people, at the rainy west coast of Norway, because there's a lot of people who have money and they invest in all kinds of companies. I'm not familiar. I do not know any investor in Germany personally, not a single one, but I know 20 of them in Stavanger. And this doesn't match up. I don't understand why that is. Maybe it could be coincidence, could be a cultural difference, could be that people in Stavanger are very wealthy. It's a different investment culture. I don't know. I just don't understand.
That's what we can have next conversation about investors.
Yes, I think we should wrap this up. It's 9 p.m.
We
here.
found the topic.
Yeah.
Okay.
Yeah. Yegor, this was great. Perfect.
Yegor, thank you very much. It was such a pleasure.
Have a great week.
Have a good evening.
Thank you. Bye bye.